Technology and Tips webcast series. Today we're going to be covering part 2 of the advanced assembly features in Creo Parametric 1.0. Thank you for joining us. For those of you that are new to the CDT webcast series, you can listen into the demo over your computer speakers, which you probably already are, but if you're having audio issues or maybe your computer is not good, you've got a good speakerphone in your conference room, feel free to flip over to the telephone radio button and follow the prompt there to listen in via telephone. Your audio will be muted during the presentation. We're going to save some time for questions at the end, so feel free at any time throughout to start typing questions into that question box, and Rosalind will queue those up and read them off to me at the end when we get to the questions. This webcast will be recorded and uploaded to our YouTube channel after we're finished. You'll find a lot of the past webcasts there, including the one that I did a few weeks ago, which is part 1 of this. My name is Brad Heuiser. I'm an applications engineer out of St. Louis for CDT. CDT, for those of you that aren't familiar with us, is a PTC value-added reseller. We call ourselves a VAR, V-A-R. We resell all of PTC's products, including Windchill, Creo, MathCAD, and Arbortext. The most common analogy, which I'm sure you guys have probably most all heard this already, is that PTC is like the Ford motor company, and we're like a Ford dealership. We sell the products, we service the products, we provide support, and just act as an interface between PTC and the smaller clients, and medium-sized clients, and sometimes even the large-sized clients. We do have a good group of guys that do integration and migration services. And with our recent acquisition of Barry-Wehmiller, we actually have a lot more services we can offer now to our customers along those migration and integration services. The one thing that does set us apart is we do have a few guys that are really good at support. We do spend a lot of our time helping out customers when we're not teaching classes and not out doing demos for specific customers. We have 3 PTC certified training centers. One in Kansas City, one in Arlington, Texas, which is Dallas, and then one here in St. Louis, Missouri. I teach out of the one here in St. Louis, and we got a couple other guys that teach out the other 2. CDT is unique in that we do classes for only 1 and 2 students. I have taught several classes with only 1 student. I kind of like it that way, actually. So you never have to worry about us canceling classes at the last minute because we don't have our quota of enough people in the class. If you guys are interested in training, you can go to our website, cdtplm.com/training, and that will take you to the training page of our website. You can register for classes directly there, or if you prefer, you can call one of CDT's fine salespeople. Also, if you're looking for something specific and you don't see it on there, if there's some kind of odd class that doesn't get offered very often, Creo Illustrate's one that we do offer that a lot of other people don't. And things like that, smaller classes that we are willing to do custom classes for only 1 and 2 students. So if you have any questions about training, feel free to contact us, and we can custom tailor something to meet your needs. So today we're going to be talking about advanced assembly again. I'm going to kind of go in a little different approach of what I did last time. Last time I did kind of a high-level overview and talked a lot about top-down design and simplified reps, and I got a lot of questions about envelopes, shrink-wrap, skeletons, and things like that. We're gonna address some of those questions specifically this week, and I'm going to kind of change up from doing kind of a high-level PowerPoint presentation overview and showing what the AAX Advanced Assembly extension is, and I'm going to go more into just showing you how a lot of the features actually work. So this is going to be a little more relaxed. We're going to take it a little bit slower and actually show you the software, which is what most people really want to see anyway. At the end, we will save some time for Q&A. Right now, I'm going to turn over to Rosalinda, though. We've got a few poll questions that we put up at this point, and we want to make sure that we get just a little bit of info from you guys, so that way we can make sure we tailor everything towards what you guys are wanting us to do.
There we go. We have 2 more. this is our last poll question. That's going to do it. It's all yours, Brad.
All right, thank you, Rosalinda. And again, guys, we do appreciate you taking the time to answer those real quickly. I know it's kind of a pain for you, but it does help us to make sure we are addressing the things that you want us to address and not just, not having a good grasp of who actually shows up for these things. So today we're going to talk about a few things. I am going to recover the slide on skeletons because I'm going to spend a little bit of time on skeletons today. But in a moment we're going to talk about skeletons. I'm going to show you how they work, and I just want to make sure that we're familiar again with what a skeleton actually is. It's a powerful tool that you can use to create 3D layout or framework and assembly design. We do a lot of things with them. Create space claims. How we, basically this is the underlying construction underneath an assembly that allows us to basically lay out how the assembly is going to function, or maybe how it's going to fit within another area without actually having to create those components. They are given some special properties. They're the first component in the model tree. They have no mass, a bright blue color, and you guys will see that quite a bit in a little bit. But what you guys are looking for right now is for me to actually jump into this demo. So first, I'm going to show you guys how to do some component replacement. We're going to open this tool here, this assembly. If you notice, let's say that this is something that we've designed. Turn off my datum features there. And right at the end, you go in and you're going to do a let's say an analysis, and we're going to do a global interference check. So we're going to preview this, and we notice that it's interfering in 4 places. And if you look, you can see that that's just because the clamp base is too large of a diameter. It interferes with the existing tooling. So we're going to have to go in and change that. Well, we found another base, off-the-shelf part, made by a different manufacturer that's a little bit different shape. Instead of going back in and redesigning this, we can go in and just replace that specific component. So I'm going to come into this clamp assembly. I'm going to activate it so we can work on it. And then I'm going to go into this specific part. I'm going to right-click, and I'm going to say Replace. When I do that, my Replace dialog box comes up. So I got lots of options here. I'm going to go with Unrelated Component because this is a completely different model made by a different manufacturer. It's not a one-off thing where I maybe resaved it, cut it, and changed it, which in this case I could have done pretty easily, but we'll say, for example, that this is a different part completely. So we're going to go in, we're going to find that base part, the square base that we're looking for, and we're going to replace it. Well, normally the way I would do this is I'd come in, I'd replace it, and when I click OK, it's going to ask me to go in and redefine, basically replace this everywhere. It's going to break a lot of references. What I'm going to do is I'm going to edit the reference table, which is going to allow me to go in and you notice I've got 8 tags here, which means I've got things that reference 8 parts of the geometry on this left base. So I'm going to go in and I'm going to say, notice it's highlighting in green the center bore there. I'm going to pick the center bore on the right, select the second one, the top face. We're going to have this top right hole. Then we're going to have the bottom of the hole there, or the counter bore. You'll see this bottom right hole, the bottom left hole, the top left hole, and the bottom face of the part. So when I do that, click OK, and click OK again. Notice it went in and it changed all 4 of those. I know this is a really small, simple assembly. There's reasons why I'm doing that. But note that I didn't have to go in and redefine this. Note there's 16 bolts I would have had to redefine. There's 4 clamps, the placement of the 4 things, the 4 bases there. Would have been a lot of redefining that would have had to done. And this, by selecting that Replace, that allows me to go in and not have to do all of that. It takes a little bit of a shortcut and allows me to do that in a much more efficient manner. So I'm going to close this out. We're going to open up another one here. Let's go to 6.2. I'm going to show you some interchange assemblies. So let's say maybe it's a part that you're changing out. You have several different designs. For whatever reason, this is part of a design. I've got this track slider that runs along a track, and I've got several different sliders that we use in our company, and we're constantly going out and constantly making new designs out of the existing parts. Well, if this is something I'm going to be reconfiguring often, instead of changing once and forgetting about it, if I'm going to switch back and forth, I'm actually going to go in and create an interchange assembly. Well, first let's look and see how this thing was built, just so you can see the function of it. Let's turn on our axes and our planes and points. And notice I do have a point right there, which is defining where that slider is. Let me turn on my tree filters here too. And if you notice, I've got this point, which is defined by this sketch. The point is along that sketch, and inside of that is defined by a reference. So if I go in and edit this point, right now, I'll just actually go in and edit the definition. You can notice it's set right now at 10%, 0.10 along the length of that curve. Let's change that to maybe, let's say, 0.75 and regenerate, and notice that the part does move and actually change angles as well. Well, I want to change this to a different part. Well, like I just showed you a second ago, I can select that part, right-click, replace, and pick an unrelated component. Well, that's not the way I want to do this, because this is something I'm going to be changing quite often. I want to use this interchange option. Well, you notice it's grayed out. It's not available. That's because I have to go and actually create an interchange. So I'm going to go in and create a new assembly, subtype interchange, and we're going to call this track sliders. And I'm going to insert a functional part, which would be the first one's track slider.prt. That's the first one. Notice it automatically goes into the default position. I'm going to add a second one. We'll say track slider2.prt. This one I actually have to place, so I'm going to click OK. And we'll place a third one, track slider3.prt. And this one we're actually going to drag over to the other side just to make sure they look nice and pretty. So these are 3 sliders I'm going to use quite regularly. Well, now I need to go in and open my reference pairing table and actually set them so that they, the Creo Parametric knows which component is which, which hole relates to which hole along this assembly. So I'm going to go into active component. I'm going to select the original component. Then I'm going to select components to pair, select the other 2 components. And then over here I'm going to select evaluate and create tags. So this creates the same tags just like we did a moment ago in our replace unrelated component function. Notice it automatically went in and created a lot of these. You can see I've got my 3 components here, and these were all created as variations of the same part. So it using the same name, it automatically knew that this axis A2 is the same on all 3 parts. So I'm going to click OK, and I'm going to flip over to my track.assembly again. I'm going to select my part, right-click, replace. Now notice I do have the option to use an interchange. When I click my open, my family tree pops up, and it's going to say, what do you want to do? I'm going to expand out my track sliders.assembly. I'm going to pick track slider 2. Click OK. Click OK. Notice it automatically places it. It's placed exactly like the other one was. If I go in and edit my point, change it from 0.75, change it to, let's say, 0.3, and regenerate my assembly. Notice it does move exactly the same way the other one did. I can go in and just simply replace using an interchange again, click open, and this time pick maybe that track slider 3, and click OK again. And when I click OK, notice now it's changed to that other kind. Well, that's fine and dandy. Do I have to go back and change, make a new interchange every time I add an assembly, delete them all off, and add new ones? No, it's really quick and easy to go in and add new parts to an existing interchange. So I'm going to flip back over to my track sliders interchanged assembly. Add another functional part. I'm going to say track slider 4. And we'll drag this one over right about there or so. And we'll turn off our planes. So now notice I have 4 in the assembly. I do have to go back and update my reference table. Note that if I scroll all the way over here to the right, it's added the 4th part in. However, it hasn't paired anything up. So I need to go back and select my active component again, select my component to pair, which would be that track slider 4.assembly. And now instead of clicking evaluate and create tags, the tags have already been created, so I can just simply click evaluate. Notice it filled most all of those out, only the ones that we really need. And we're going to go flip back over to our assembly, to take this track slider 3. Oops, don't want to hide it. I want to replace it with an interchange, and this time I want to expand this out. Notice it's showing me 1, 2, and 4 because 3 is active. It's not showing me 3 because 3 is already there. So I'm going to select 4, click OK again, and notice it changed, and I can move this point just like before. Say move it back to point 1, and it's a functional part of the assembly just the same way. And I know you're probably saying, well, these are pretty simple, easy assemblies. You know, what's the point of this? Because, you know, my assemblies are way more complicated than this. You know, I could do something very easy just by redefining a couple things, and maybe, you know, deleting something and adding a new part in. Well, that's not the point. The point is this is for something where maybe you're constantly changing parts out. You're having different track sliders that mate to a track. Maybe this is a very large, you know, 3,000 component assembly, and it's just a lot easier to use interchanges that way. So that's some of the simpler kind of fun stuff to show you. Now we're going to switch over and talk about some shrink wraps, because we did get quite a few questions about shrink wraps last time. So we're going to set our working directory. We're going to open. Let's see, shrinkwrap model.assembly. Where are you at? There you are. So now we're going to come in, and the point of a shrink wrap is to take a large, complicated assembly, you know, with lots of components inside of it, and to actually create another part you can substitute into that assembly, maybe using an envelope, to simplify how this fits into an assembly. If this is a really large assembly, I don't need to know, you know, all of the details of the piston and the crankshaft and the connecting rod inside. I just want to see maybe the overall geometry, the overall surfaces. So I'm going to come in here to File, Save As, Save, File, Save As, Save a Copy, and I'm going to type down here at the bottom. I'm going to scroll down. I'm going to select Shrink Wrap. Where are you at? Yeah, they couldn't put these in alphabetical order, could they? There we are, Shrink Wrap. So we're going to leave that shrink wrap model SW.004. And I'm going to click OK. And in the dialog box, I'm going to say I want to fill the holes. I want to make sure I assign mask properties, so we're going to check that. And then down at the bottom, I'm going to say I want to use gray and orange color. So you notice we're going to leave it set to level 1 at first. We're going to click Preview. Notice the orange surfaces are the ones that are going to be excluded. So if you notice, there's lots of surfaces here that are going to be excluded. So maybe I want to crank up my detail level just a little bit and say maybe I want this to be a level 4. Click OK. That's just an alert saying, you know, hey, you're going to change some stuff here. Now if I click Preview again, notice that a lot of those orange surfaces have gone away. I still have some. Still going to exclude a lot of these, but my geometry is a little more accurate to what I want it to be. So as if you notice down here at the bottom left here, 588 of 1,311 surfaces have been kept. If I change that level, let's say we'll change it all the way up to 8 and click Preview. You notice it takes a little bit longer to think about it. It's calculating. And now notice I have very little orange. If I look up at an angle, I can see, you know, some of the holes. There was a hole through there that's been basically eliminated. And now it's 722. Well, you know, maybe 4 was what we actually wanted. So we'll click Preview again. Notice that calculated much faster, 588. So we're going to change the name of this. We'll leave it 004, and we're going to click OK. And then accept that default relative accuracy there. And we have another type of option. So we just created one. I'm going to now create a faceted solid. And this time we're going to click Preview, leaving that at level 4. Notice that's not really very good looking. That's pretty horrendous actually. So let's crank up the level to maybe 8 again. Notice 982 triangles produced. Click Preview again, and you notice now that's a little more like the shape we want. You know, it still looks pretty hairy, but that's something that's going to be you know, probably something that we're going to use just for showing a placeholder. You know, the engine is going to be roughly about here. So we're going to click OK. and let that generate. And then we're going to create a third one, merge solid. And this one we're going to crank the level back down to 6. Click preview, and notice it's going to give you pretty much everything you had before. It's got a lot of it kept 7 of the 16 components. So we're going to click OK, and we're going to click close, and I'm going to open another file here. So we're going to open a Shrinkwrap compare assembly, so you can see those 3. Actually, these are 3 that are created before, 1, 2, and 3. I just created 4, 5, and 6 to show you, but these are the 3 that I created earlier using those same specifications. And if you notice, there is quite a bit of difference between the 3 of them. If I go to the no hidden, it'll show you, the orange and the purple show you that this is not, a normal part. You can see here, this retains most of it. This retains, a lot of the geometry, but it's good for pretty much just a placeholder. So the faceted solid's in the middle, obviously. The surface subset's on the left, and the merged solid is on the right. Excuse me, got a dry throat. Allergies are getting really nice again this time of the year. So now you're thinking, well, what's the point? Well, why would I want to use these? I'm going to flip over to another example now. And this is the camera example that I talked about a couple weeks ago. So we're going to select the working directory, and now we're going to say we want to go to solid Shrinkwrap envelope. I'm going to create a Shrinkwrap and actually use an envelope to put it into an assembly. So now we're going to open, and we want to go to, let's see here, camera1.assembly. There it is. If you notice, I'm going to flip back to my shaded view here. So this is the camera that I've talked about in the past. Obviously, it's kind of small. It only has maybe 100 components or so. Probably not even that. Probably 75. But you can see it's got all the way down to specific resistors and capacitors on the board. And there's a lot of other. If I flip over to a hidden line view, you can see there's a lot of detail on this board up here as well. There's lots of components that are being shown, and for whatever reason, I don't want to show these in my final assembly. I want to actually take this and make it a solid. And the reasons for that may be that maybe this is a really large component. It has thousands of parts in it. Maybe this is that lawnmower I showed last time, and I don't want to show all those internal parts. I don't want to have to regenerate all those because that really saps all my system resources. Or maybe it's just as simple as I'm sending this component, this assembly, out to the manufacturer that makes the stand that it sits on, and I don't want them to know all of our proprietary data that's hidden inside. They don't need to know all of that. All they need to know is the rough overall shape. So I'm going to go to our Manage Views and open my Envelope Manager, and I'm going to click New, and I'm going to change the name of this to Solid Cam because I'm going to actually create a solid from it. And I'm going to select all of the components. So I want to make sure that all of them are included. I do that because click OK, or click Envelope part. You want to make sure you select all of the components in an assembly because then the envelope that I'm creating will allow me to substitute for the entire assembly. If I don't select all those, it won't allow me to substitute it for the entire assembly. So now that I've done that, I want to click All Solid Surfaces, subset Shrinkwrap, and I want to assign it a name, Solid Cam ENV for envelope. Notice that we do commonly put E and V for envelopes. That way, from looking at the model tree, you can quickly and easily tell that this is an envelope of that Solid Cam part that we're doing. So now I'm going to click OK. So I want to copy my geometry from, let's see, milligram, kilogram, second. Where are you at? There you are. Milligram, kilogram, second, .prt. Click OK. And yeah, go ahead and click OK there as well. So now I'm going to click my subset button. and I'm going to actually select which components I want to keep. And really, I only want to keep the housing, so I'm going to go ahead and expand all these out here so I can select. I want to pick the housing bottom. Let's actually first turn all of these off. Yes, I want to continue. Ignore all of them. I'm going to select the housing bottom, then I'm going to select the housing top, and then I'm going to select the housing front. Then I'm going to click OK. Now in the options over here, I'm going to say solidify resulting geometry. And I want to fill contour surfaces. So I want to right-click in the graphics window. I could select fill contour surfaces, or I could click over here in the fill contour surfaces box. And I want to fill in this front surface here and hold down Control and select this back surface here as well. And that's just going to fill in those holes. Now when I click Complete Feature and click OK, click Close here, I need to go back to my tree filters and turn on my envelope components. Click OK. Notice now I do have solidcam.env. If I open this guy up on its own, you'll see it is a solid component. It is not one external shrink wrap of 3 components. It's not an assembly anymore. If I show you no hidden, or I guess I need to show you hidden line to show you the inside. It does retain the geometry of the ribs and things that are inside the plastic components. However, it does not show you any of the circuitry, the circuit boards that are in there. So you're saying, okay, that's great. What now? Well, let's close this guy here, and let's actually open up securitycam.assembly. Let me toggle back over to this other one here and make sure that I've got everything set right here real quick. So in my view manager, I can set, well, I don't need to do that. I can do that in the other one. So I'm going to go over to my security cam, and notice it's kind of laggy as I'm twirling it around. It's kind of jumping. I don't know if you guys can notice that on the webinar or not, but even a small assembly like this with this many components, it's really kind of choppy. You can tell it's taken a lot of RAM to actually generate this and make it to work. So I'm going to come in here and expand up my camera1.assembly. I'm going to select this solid cam envelope part, set representation to envelope. Notice it did change it now. My part spins around much easier. It's a lot lighter weight. I'm going to go into my managed views, and I'm going to save my master rep as solid cam. Click OK. Now notice I do have a solid cam. There's the one before. Notice it's choppy as I'm trying to spin it around. I go back to my solid cam. It's a lot smoother. But here's where you can really tell the difference. If I go to File, Manage Session, and Erase Not Displayed. Manage Session, Erase Not Displayed. Well, it's not going to show me. I'm showing you in the wrong place. I apologize. But it'll show you that I can delete a lot of those. So if I need to change my master rep here to solid cam again, but it would show you that it's deleting all of those. All objects in current session are currently being displayed, can't be erased. Okay, so if I go back over to the other one, you can see there are a lot of components here that will not show up anymore that I don't need to load into the RAM anymore. Oh, that's why, because I had the other one open. So now if I go to File, Manage Session, my apologies, Erase Not Displayed. Now, there we go. I didn't realize I had the other window open still. You can see all of these components now are no longer in the RAM after I erase them. So now I can go in and lighten up the resources that are being required by my system to open this part. So now we're going to move on to skeletons. This is where we're going to spend probably a good chunk of our time today. Let's see, it's already 12:30, so we still have plenty of time to show you the envelopes. But set our working directory to here. Make sure I get this absolutely right here. We're going to do a couple of things first. I'm going to skip the first step, which is creating the basic assembly structure. I can just open the next step in the file and show you that. So I'm going to go to AX2. We're going to go to 11 skeletons, and we're going to open skeleton space claims here. So we're going to set that as our working directory, and then we're going to open ac40.assembly. The first step would be me going in and actually creating this assembly here, which is, as you can tell, there's nothing in it but a bunch of planes and axes and points. Actually, there's no axes in this either yet because we haven't started to create the skeleton. But I've created the basic, using top-down design, I've created the structure of how to make this assembly. It's going to be an engine on a frame with a block, a crank, a piston, and a rod, and then some bolts that hold it to that frame. So we're going to go in here, and I'm actually going to turn off all the displace types except for planes. We want to keep showing our planes. And I'm going to take this main skeleton.prt, and I'm going to open it. And then inside here, I'm going to go and I'm going to start creating my skeleton. So I'm going to create a plane, offset this top edge here. Let's see that needs to be 54. And we're going to change the name of this to height. Click OK. Now I'm going to, from that top, with that plane still active, I'm going to click extrude, and I'm going to create a circle on that plane. If you notice in Creo Parametric, it did not reorient to my sketch view. If I wanted to do that, I could just click that right there. And then we're going to say this needs to be a diameter of 21. And we're going to click OK. We're going to create this as a surface. And we're going to have it so that it goes until that top plane. Notice it turned blue because this is a skeleton. Now we're going to select the front plane and create another extrusion, another circle based around the origin down there. This one's going to be a diameter of 28. Click OK. Make this one a surface as well. Make it a symmetric extrusion. And we're going to say this one is 32. So there we've got the basic skeletal structure of the engine. I'm going to go in and add some datums to it, create some planes. But if you notice, I can come in here just like any other solid geometry and edit, and it's just like a normal extrusion. I can change the length of it or the diameter of it, just the same way we always have been able to. All right. So I'm going to take these two extrusions and merge them together. So I've got my merge command right there. And I want to flip these arrows so that they're pointing those directions. Notice that that's the parts it kept. It cut the center out there. And it cut the center out down through here. And click to complete feature. And if you notice now, it is one feature. It's blue because again it's skeleton geometry. And then I'm going to take this and do some work with it. I'm going to go in and actually place some other skeletons inside of it. But before I do that, the way this is set up, I'm going to actually close this file and open another one that's identical to it. So close that file as well. Erase not displayed. Now we're going to open up skeletons, and we're going to say skeleton placement. Set that as our working directory. Open that up. Open AC40 again. And this time I'm going to turn off my planes, and I'm only going to turn on my axes. So I'm going to take my main skeleton part here. Notice it's the first one in the tree, and it does have its own unique icon there. We're going to open it, and then we are going to add some datum axes in here. We're going to select this here. We're going to name this, change the name of this to cylinder, CYL. Then we're going to insert another one in the bottom down here. We're going to change the name of this to crank. And then we're going to come in and create from the top plane here. We're going to select our top plane. Or I guess, actually, I'm sorry. I need to turn my planes on. So you can see I'm going to offset some planes first. First I'm going to offset a plane off of here. We want that to be offset 10. And make that 20, make it spaced out just a little more. And then I'm going to create an axis. With the datum axis tool selected, notice it did select datum plane 1 already. I'm going to select a plane tool on top of that. I'm going to pick this front plane and offset that 20 in that direction. Or no, this is the one that's supposed to be 10 here. When I click OK, it brings that plane, datum plane 1 and datum plane 2, both into the axis. And I'm going to actually take this axis and change the name of it to hole 1, and then take the display and adjust the outline down to a reference of this top face here. Notice that the axis did get shorter. Click OK. Well, maybe I want to take this one here and change that as well, but that's not necessary in this demo. So now I'm going to take this, I'm going to put multiple skeletons in here, so I need to go into my file, and we'll open up the next file as well. So again, these are all building off of each other. So we're going to go in, and having it laid out like this is really good in case something were to happen in the middle. And I have been known to push Pro a little too hard. It gives me a good starting point, so I'm going to come skeletons multiple, and I want to make sure that I set that as the working directory. Open this guy up, and I'm going to open AC40 assembly again. Notice here's a lot of the other datums that have been added in that you don't want to watch me add all of the datums in. I'm going to go into my config options. If you notice in Creo Parametric, it's a little different now. You go to File, Options, and Configuration Editors right there. I want to make sure that my multiple skeletons allowed is set to yes. By default, that is set to no. So you want to make sure that that is set to yes. And that'll allow you to put multiple skeletons in. So now I want to come in and take my frame and my engine assembly, right-click and hide those out, get rid of those datums. I don't need those right now. And I'm going to create a component. And I'm going to pick a skeleton model. And sorry, I need to back up one step here. I need to select this guy here. Model display, component display style. Say transparent. Make that a little bit lighter so you can kind of see through it a little better now. So I'm going to come in here. I'm going to create a skeleton model, and we're going to call this one crank underscore skeleton. Click OK. And I'm going to copy from crankgeometry.prt. Click Open. It's going to ask me, do I want to leave it unplaced? No, I want to actually go ahead and place it. So we're going to come in here and we're going to use a pin connection. And we're going to say we want that axis there and this axis. And then we want to select the front plane and the front plane there. And that gives us the placement there that we want. We want to come in and create a couple more of these. The next one we want to do is the piston. So we're going to call this one piston underscore geometry. I'm sorry, not skeleton. Hit enter, and now we browse to the piston geometry. Click OK, and we're going to place this one using a slider connection. Pick that axis and this axis down here. And then we're going to pick the front plane and the front plane here. And we're going to go ahead and drag it up to roughly about where it's going to be. Now we're going to come in, we're going to create one more. We're going to call this one rod skeleton. And we're going to find this one from the rod geometry. We're going to copy the rod geometry part that's already in there. And this one we're going to come in, we're going to say we're going to put a pin connection on the bottom and a cylinder connection on the top. So we've got a pin, I'm going to connect to there. And then that front plane there, we're going to snap to this plane here. And then we're going to go into our placement tab, click New Set. We're going to come in and we're going to select, change it from a pin type first to a cylinder. We're going to pick this axis here and that axis there. Notice it did snap those together. And my little 3D dragger has been all grayed out. I have no more degrees of freedom that I can use on that. Well, I have one, but that's just the degree of freedom of the mechanism. So now I'm going to turn my planes off, my axes off, so you guys can see I've got a skeleton that's a realistic representation of an engine that we're going to build, and I can come in here and actually drag it through its full range of motion, and it will function the way that the final engine will. But I don't need to know all of the details of how parametrically to create the piston or the crankshaft or the rod. I just need to know roughly their lengths, that sort of thing, and I can create my my assembly from this. So now you're saying, well, big deal. Skeletons don't really, I can't give a skeleton to a customer. I need to create some solid geometry. Well, how am I going to do that? Well, let's open up the next section here. We're going to close out of here. Erase not displayed. We're going to set the working directory again. This time we're going to pick sharing skeletons, which is going to allow us to go in and take that geometry that we've created and go in and make sure that we can create solid geometry from that. So first I'm going to go in here and I'm going to make sure all my datum types are turned on. I want axes, I want points, I want coordinate systems, and I want planes. So I'm going to go in here and I'm first going to open up this first engine block, and I'm going to say I want to get data. I want to go copy geometry, and I want to excuse me, click open. I want to turn off the published geometry only. I'm going to click open, and for the block here I want to select main skeleton, and in here I need to go through and select that I want which coordinate systems I want to select. The where's my model? I want to go through, click open. Yes. Main skeleton.prt. All right, something's not popping up that normally pops up here. There we go. So I want to pick my main skeleton again, and I want to go to my options here. References, published geometry, not published geometry, surface sets. I want to first get this entire surface. I also want to pick up this chain that's right here, and I also want to pick up these holes, cylinder, let's see, this offset plane, this whole plane, and that whole plane there as well. So I do that. Notice it comes in. It does turn it blue. This is copied geometry. It's not actually a skeleton. It's just copied geometry. So notice I'm going to come in and create two holes and a fin from this in just a moment, which actually I could go ahead and do that from here, but I want to make sure I get all of my references properly. So let's go ahead and close this one out here. Erase not displayed. And I'm going to go to skeletons, set my working directory, skeletons, placing models, and I'm going to open this first AC40 again. From here, I want to make sure, of course, that my allow all skeletons is still set to yes. Multiple skeletons allowed is still set to yes. Sometimes when you open different models, it may change. What I want to go here and do is I want to select the this first assembly. I want to actually open the engine assembly and take the block, right-click, select open. So if you notice, it is blue. You're thinking, well, that's a skeleton. Well, no, it's actually not a skeleton. If I go to my appearances, clear all appearances, yes, remove all appearances. Notice it's purple. It's a surface. It's another thing about Creo Parametric. They did update the colors a bit. So if you see something that's purple, that is a surface. It was blue because I copied it from existing geometry. So now I'm going to come in here and I'm actually going to create geometry from this. So I'm going to select my copy geometry, go back to my model tab and select thicken, give it a thickness of 2, and click OK. Now see, I do have a solid part now. I also want to go in and pick my top plane, say extrude, use my project and select loop and pick this edge right here. Click close, click OK. Set the thickness of this to 4. And I want to come in and add some holes in here. So I want to select, let's turn off our planes. They're getting in the way now. So I'm going to leave my axes on. I'm going to say I want to select this here, hold down Control, select that to get a coaxial hole, right click, select through all, make sure that's set to 3, which it is. And then with that still selected, I'm going to hit Control C to copy, and Control V to paste. I'm going to select the other axis and the other surface. Notice it places an identical hole right next to it. And that allows me to go in, and now see I've got solid geometry that was created. So I'm going to go in and select my copy geometry, right click and hide. Notice that little blue edge that was there, the other geometry is gone. This is an actual solid part now that I can use to create my assembly. Well, the really cool thing about this is I'm going to go in and let's flip back over to the assembly. Notice now I could go in and do that for all of these components, which you guys would probably get bored if I did that, and we don't have enough time to do that anyway. But if I go into my main skeleton, which everything's based off of, we created an almost identical skeleton to this earlier. Let's say, for example, I want to edit this. So instead of 5, let's change this to 15. And maybe I want to regenerate. I want to take this top part here, and I want to edit the height of this, or maybe the diameter of this from 21 to 25. And we'll take this bottom section here and edit, extrude to, edit the definition of that to, instead of 32, maybe we'll make that 55. So we're drastically changing the design of this. Instead of having to go back to an engineer and say, hey, I need you to update that entire assembly, I can simply go in now to my assembly, and if I update my assembly, notice the parts update with the skeleton. So you've got all those critical dimensions you need right there at the very beginning in that initial skeleton, and when you update that, you can fix that so that it does let you change the overall function of an entire assembly without having to go in and edit specific components. Everything in this assembly mates to the skeleton. So notice that this component here did even get longer. The piston is not referencing that other diameter, it's referencing its own skeleton, so it's not going to get bigger unless we edit that skeleton. But everything did update dynamically. That being said, we are right now at about 10 till we got another couple minutes. There's a couple other things I'd like to show you real quick. If we go over to one of the kind of more fun functionality of advanced assembly is copying and pasting. So let's erase not displayed, set the working directory to copy and paste, and we'll open up this copy paste assembly. So one thing most people don't realize is to place bolts. If it's simple to place bolts, on a large group of something if they're in a good geometric pattern. But in this case, I've got 3 bolts up here. They're not really patternable, and I've got 2 more bolts on bottom. Well, I can select this bolt, hit Control C to copy, or click here to copy, and then click paste, or hit Control V to paste. Notice now it's placing another bolt. I can simply, using a temporary interface, I can select the bore of the next hole and the surface. I can come in here, Control V, and paste another one here. Control V, paste another one here, and Control V, paste the final one there. And that saved me a lot of time in placing 5 bolts. It does use a temporary interface. You can set interfaces for things permanently. If let's say that we have a bolt, I'll back up to another one here. Placing interfaces, where I can come in and create an interface on a bolt. So let's say we're going to open this bolt, and this is a bolt that I'm going to be putting in lots of assemblies. Typically, bolts go in with 2 references, a bore and a surface up here. So what we're going to want to do here is allow us, to take a little bit of a shortcut and to constantly, instead of having to go in and if I place 100 bolts, place this bolt 100 times, that's 100 times I have to pick this surface and 100 times I have to pick that surface. Well, I can create an interface by going here to my component interface, and notice we'll call this one insert mate, and we're going to change this to a, we're going to pick this surface here, hold down Control, select, let's see, new constraint, click this surface here, and that allows us to go in, and now we've created an interface. If you notice in the footer here, we have an interface that allows us to quickly and simply go in and place this into another assembly. So if I go to my placing interface here, I'm going to assemble, I'm going to pick my placing bolt. Then notice it already pre-selected that surface there, so I can pick there and pick there, insert it again, placing bolt. I just pick the bore and the surface. Again, placing bolt, pick the bore, the surface, and you can see, and you say, well, maybe I don't always want to do it that way. I want to offset it once off of here, so pick the surface, and then I can go back in and edit it, just like change it from a coincident to a distance. But that saves me a lot of time in placing large numbers of components. It's one of the more time-saving things that we that I've picked up over the years using Pro 8. Because typically bolts are always placed using a bore constraint and a surface constraint. Again, I wanted to squeeze those in at the last bit there because interfaces are extremely valuable with large assemblies. At this point, I guess we've only got less than 10 minutes left, so let's flip back over to the final slide here. If you guys have any questions at this time, we can ask questions, but I know we don't have a lot of time, so if you guys want to have maybe a more complicated question that you don't think we can answer now, feel free to email it to myself or to Rosalinda, or give us a phone call. Our numbers are there. And especially if it's a really complicated one, we feel free to ask it, and if we don't know it, we'll find someone that does. So at this point, I would like to open up the floor to questions. Did we have any questions, Rosalinda?
George and John both have their hands raised. Well, George does. George, I unmuted you if you have a microphone, if you want to ask a question. Oh, there we go. Yes, George. We can do that. Do you see that, Brad? Can we do a third seminar which covers Creo-specific enhancements?
Yeah. I mean, there's honestly there's a lot more that can be covered here. I mean, there's a 3-day class just on the advanced assembly extension. It's I hate to do too much more because then PTC is going to get mad at us for teaching their class for free. But that's we would absolutely if there's something specifically you would like to see, by all means email it to us. Again, that's something that I try to bring up on all the webinars we do, is that we do look for things to do webinars about. We do have like the next month or so planned out. But yeah, absolutely, if there's something you guys would like to see, by all means we can.
And also, Brad, John asked, how can you make an existing sim rep the default rep?
So an existing rep, if you want to make it the default rep, then you would just save it as the default rep. You can't save over the master rep, but you can save over the default rep. That's one thing that I get a lot in my training classes. They ask, why is there a default and a master? Why do you have two that are the exact same thing? Well, that's because the default rep you can change, the master one you can't.
And also, George, the enhancements he's talking about is like the lightweight graphics. As far as
let's
enhancements.
I mean, I don't know if I have enough material to do another full third webinar on this, but by all means, George, I'll get together with you, and if you have any questions specifically, we can talk through them. And then if there's not something that's answerable, then I'll go get someone that does know how to answer it. Fortunately, I do know my limitations. Okay, so we had another one pop up. Second to lightweight graphics rep. Yeah, okay. Yeah, if we get some good interest in that, I don't know if I can make a full webinar out of it though. Unfortunately, maybe we can combine it with something else. With that being said, it is 12:56. I appreciate you guys all sticking around and letting me kind of do something a little more detailed than last time. I know I didn't like doing the one last time because it seemed like it was too much talking. I like playing with Creo more than I like. I'm sorry, Creo more than I like talking about it.
And also keep in mind that if you subscribe to our YouTube page, anytime I post a webinar video up there, you'll get notified. So that's one way to kind of keep track of what's going on if you can't attend our webinars. And as always,
we've got several of them. We've got 20-something of them up there right now, don't we, Rosalinda?
yes, we do. And this afternoon I'll be shooting out an email. Hopefully everybody gets it and I don't get a spam. But I'll be shooting out an email with the webinar link for today's webinar.
Great. Well, thanks again, guys. I appreciate you popping in and letting us show some stuff to you. Again, feel free to call or email us at any time. One thing to note, our email addresses did change with the acquisition. I did update them both there on the slide. We still do get emails at the old addresses. However, I don't know how much longer we're going to be getting those. So please, if you email us at the new addresses. Mine's brad.heuiser@cdt-bw.com. And Rosalinda's her first and last name as well. Thanks again, and I will see you in another few weeks. Hopefully you guys enjoy the one that we do next week.
Okay, and next week is Creo Simulate. Everybody have a great day.